This is the query processing architecture module, and in all videos related to this module we have discussed about the structure of the select query. When the select query is passed to the database engine, how this database engine will behave with this query, what the optimizer will do with this query. In this video we will study if there is any constant expression is coming into the select query, what will be happen with this select query when it will be passed to the database engine. For example, this is an select query, select count of asterisk from products to where item ID is greater than or equal to 30 plus 71. Now this select query has a constant part 30 plus 71. So when we pass this query to the database engine, what the database engine will do with this constant part, how this will be evaluated. When this query is passed, the optimizer evaluate this constant expression earlier before the query is uh, completed, before the query is compiled. This constant part is already evaluated. This behavior is known as the constant folding. For example, this is the diagram for query processing. When this constant query select count of asterisk from products to where item ID is greater than or equal to 30 plus 71 is passed to this database engine, parser will parse the query, and then this logic in this logical tree, the constant folding will be happened. In this constant folding, what the expression will be evaluated. 30 plus 71 is equal to 101. So 101 will be stored in this logical tree when this constant folding will happen. And this constant folding, we can see here that is happened before the optimization is start. This constant folding will give the performance benefit because when this now query is after this constant folding, query is now going to the part of the optimizer now knows the exact size of this record. This when this constant folding happened, so it will becomes 101. So now the optimizer know that all the records, only those records will be fetched which are greater than or equal to 101. So the size of the records the optimizer knows, so it will give the performance benefit, it will make more accurate query plan. So this constant folding has the performance benefit. Now if I will go to this query analyzer in the database engine, from there we can check the behavior of this constant folding. So this is our SQL Server Query Analyzer. In this SQL Server Query Analyzer, I will check the behavior of the constant folding. And this is our example database, TradingDB. And here I will use this query, select item ID description, get date from products to where item ID is equal to 1 plus 5. This 1 plus 5 is a constant part. So here the constant folding will occur, and when the constant folding will happen, it will evaluate this 1 plus 5 earlier before the optimization is start. To check this behavior, I will I will check from the query tree, which is also known as the logical tree. To display the query tree, to check the query tree, we use this query trace on flag 8605, and to display this query tree on our screen, we have to use this dbcc command, trace on 3605. So let's see what happened with when I'm executing this query. In this query tree, we can find out this is the when the query is processed, the logical tree is created. From this query diagram, we can also see that the logical tree is creating after this parsing is happening. So this logical tree, which is also known as the query tree, have all the logical steps to execute this query. And this is the logical tree. In this logical tree, this is the uh, logical step SQL op compare x underscore cmp equal. So this is the where part. In this where part, item ID is equal to 1 plus 5. So 1 plus 5 from this logical tree, we can find out it's already evaluated, it's become 6. So this is the constant folding, and we can also find out from this actual execution plan, which I already enabled for this query. Also from this actual execution plan, if I am going to this check the properties of this cluster index seek operator, from this operator I can also find out the predicates. This is the seek predicates. It will find the item ID, this 1 plus 5, and here we can also find out, if I am going to make it big. So from this we can find out that this is the seek predicate. Here we can find, if I am making it like this, that this item ID is equal to scalar operator into 6. So this 5 plus 1 is equal to 6 is already evaluated. So it's now this operator, seek operator, is checking the value for 6 only. To make it more clear, I will use another query. The same query I will use, and here I will add with this constant expression 1 plus 5, I will add the item ID column. So now what the query will become, select item ID description get date from products to, where item ID is equal to item ID plus 1 plus 5. So now the query has the, with the constant part is the column ID is also added with this constant portion. Now this is no more the constant folding. This is no more a constant folding expression, because when we are adding any variable, we are using any parameter or column name, then there is no more any constant folding is happening in the query. For the constant folding, only there should be the arithmetic expression without variables, without parameters, without any columns. So to let's check the logical tree and the execution plan, what's happening with this query. So now if we are going to this logical tree, we can find out in this logical tree compare part, where part, that this is the where part of the logical tree. Here we can find out now the 1 and 5 is treated separately. The tree has break these steps into the two parts, 1 and 5. Before it was one part. 5 plus 1 is a 6. It's evaluated, but now when we use this column, when we used with this in this query with the column ID with the constant, now there is no more constant folding. No, this constant expression is not evaluated. It will be evaluated during the execution time. So if we are going to check this behavior in the execution plan, and I'm going to check now again the cluster index skin operator properties. From these properties we can find out that these are the predicates. In this predicate we can find out that the item ID is equal to item ID plus 1 plus 5. So whatever we have written in the query, it's in the predicate is coming as it is. And in the previous, when the constant folding happened, we see there that 5 plus 1 is equal to 6 is coming. So here there is no constant folding is happening when we are using the variable column name or parameter name with the constants. So it will make more clear when the constant folding is happen, when it will not happen, and we can find out from this execution plan, from this logical tree. So constant folding will give the performance benefit